Welcome class to this video, section 5.2, Interpreting Distance Time Graphs, part 2. In this video I'm going to go over a few different graphs and what the lines on the graphs reflect about movement in real life. So we covered quite a few of the basics, but I did want you to have a deeper understanding and hopefully you will gain that through watching this video. So the first thing I'm going to show you is now we have two runners. We have a red man and a blue woman. And if you look at their graphs, you can only see the blue line at the moment, but there's two lines there. You can see that there now. Okay, if you look at that, you can see there are two lines and they are horizontal, lying across the horizontal axis, the x-axis. And I want you to make a prediction. What do you think is going to happen if I keep the lines horizontal like this along the x-axis when I press the green button? Okay, make a prediction. Are you ready? Okay, that was a little bit anti-climactic, but nothing happened. Because what this line being horizontal here at the on the x-axis means is that they did not move. As you learned, a horizontal line reflects the fact that the distance from the fixed point is not changing. And they were at the starting line, that's 0 meters away from the starting line, which means they were at the starting line, and their distance did not change for the entire 4 seconds. So they both just stood there with their hands on their waist. So the reason I've shown you that first graph with the two lines lying horizontally along the x-axis is really to communicate this idea that when on the graph you see a line making contact with the x-axis, it means they are 0 meters away from the fixed point, and it means therefore that they are at the fixed point. So if you're looking at this graph here, can you predict what's going to happen with the blue woman? You already know that the red man is going to stand there for 4 seconds. What do you think the blue woman is going to do? Let's click and see. Hopefully you were able to predict that she would run back and forth. The first part of the graph, the first line segment of her graph shows that she ran away from the starting line to a distance of 40 meters away in under 1 second. She's running quite quickly. And then she ran back to the starting line, away again from the starting line, 40 meters away, back right to the starting line, and then again she finished 40 meters away after 4 seconds. Okay, good. So now I want you to take a look at this graph here. And I've gotten rid of the animation for a moment because I wonder if you can understand what this line means. And it's very important to understand what it means from the very start of the movement, the motion. What is the first point on this graph? It is 0, 10, which means at 0 seconds, the runner is going to be 10 meters away from the starting line. So are they going to be starting at the starting line? The answer is no, they will not be starting at the starting line. Let's show both the red and the blue runners. And let's see how that works. So we can see here that we have the red runner is 0 meters away at 0 seconds, so they are at the starting line. But the blue runner is 10 meters away from the starting line right at the very, very, very start. Okay, and you can see now if I change and drag this here, I can have her be as far away from the line as 40 meters because that's all the graph gives me. But you can see how it changes where she starts. So if you had, for example, a question that said the person is 10 meters away from starts 10 meters away from the starting line, then you would have to place it here, 20 meters away, 30 meters away, 40 meters away. This is their starting point. Okay? What about this graph here? Any predictions about how it's going to look from the start? What's going to transpire when we press the green button and watch the movement reflected in the graph? Let's take a look at how the animation is going to look from the start. You should know that the blue runner is not going to be starting at the starting line. They are going to be starting 10 meters away from the starting line. You should know that the red runner is going to be starting 40 meters away from the starting line. Now, you should know, based on everything we've learned before, what the blue runner is going to do. The line is going up to the right, so the blue runner is going to run away from the starting line. What about the red runner? The line is going down to the right, and so the red runner is going to run toward the starting line. What do you think this point here means? What do you think this point here means? We call this point an intersection point. And let's click the green button and see what happens at that point. Did you see it? At this point here, so just somewhere in between 1 and 2 seconds, the red runner and blue runner cross paths. Okay, and so intersecting lines on the distance time graph means that at that moment in time, they're the same distance away from the starting line. And so presumably they are crossing paths. All right, we're going to have a race. It's going to be the blue woman versus the red man. Who do you think's going to win? If you look at the graph, you can see that the red man is starting 10 meters away from the starting line, and the blue woman is starting right at the starting line. The question is, who is going to reach this 40-meter line first? If you look at the graph, you can get a pretty good idea of who that's going to be. Do you have an idea? Let's watch and see what happens. It's close. It's a tie. That's right. No one won. Why? How can I tell from the graph that no one actually would have won this race? Well, I can tell because both runners at 4 seconds were 40 meters away. So they reached that point at the exact same moment. Alright, so that's enough for the gizmo for now. I want to help you out with activity 1, which asks you to write in words the story that the time distance graph to the right reflects. Now I've changed the time distance graph slightly. I've added the points for every end at the beginning of every end of every line segment, and I've added letters to represent those points. I added the time down here on the x-axis, the label, and the label for distance from home on the y-axis. I've also given my graph a title, Marcus's walk. And over here I've used words to describe the movement that is reflected in the graph. And I'm going to read you the story and just go over how it reflects the graph so you can have a really strong sense of how this is done. We will then go through the process of determining the speed for each line. This activity 1 and me doing it with you is really just so that you are able to do the other activities on your own. Alright, so the first sentence says, Marcus walked from home towards school. So you can see here it's 0 kilometers at 0 seconds. This is at home. He's 0 kilometers away from home. He's at home. And he walked towards school, and he walked away from home, but stopped at a store 3 kilometers away after 1 hour. Okay, so you can see that here. He's 3 kilometers here at this point away from home. He's in the store, and he stays in the store for, how long does he stay in the store? He stays for half an hour. You can see each of these lines is going to be worth half an hour. Alright, so he hangs out in the store for half an hour. He then walked another hour toward school, arriving 2.5 hours after he had left home. Now this is very important because lots of students get confused here. What I want you to notice about CD, this line segment here, is that 1 hour has passed from the time he left the store at C to the time he arrives at school at D. 1 hour has passed for that section of travel. Overall, it's been 2.5 hours since he left home, and you can see that here the 2.5 hours since he left home. But this line segment, and when I'm calculating the speed of it momentarily, is going to be calculated as 1 hour of time passing, because we want to know his speed when he walked from the from the store to the school. All right. So 1 hour passed, 1 hour walk, but 2.5 hours overall. All right. He stayed at school for 5 hours. So you can see this long horizontal line here represents that, from 2.5 hours after he had left to 7.5 hours after he had left home. He then walked directly home in half an hour. I mean, you can see he really books it home. It's not like section AB or section CD where he was daydreaming, probably writing a song in his head or something like that. He books it home for EF. All right. Now let's calculate the speeds for Marcus's journey. First, we're going to look at line segment AB. When we calculate speed in a distance time graph, we find the rate of change of the line. So we find 2 points that we can clearly identify. This one is 0, 0. The first one we're going to identify is 0, 0. The second one is 1, 3. We draw our right angle triangle from here to here. We went from 0 to 3, so we went up 3. We went from 0 to 1, so we went over 1. So that makes our speed, which is distance over time, 3 over 1, which gives us a speed of 3 kilometers per hour. And I guess now, if we really think about it, Marcus wasn't walking so slow after all. But man, his school is far. All right, let's look at BC. BC, we find the 2 points that we can clearly identify, B and C. And we see that there was no change in the distance, but there was a change in the time. It was half an hour, so 0.5. So distance was 0, distance over time, and the time was 0.5, right? So 0 divided by 0.5, and we get 0 kilometers per hour, because it means that Marcus was not changing his distance, he was not moving. Now, of course, you could say he was moving within the store, because we said he stopped at the store at that point, but it's a fixed point, that store, and the store is not moving, and so we're thinking of his distance in a more general sense as not moving, and that's why the line is horizontal. Horizontal line represents no movement. All right, so CD, you can go from C to D. We draw a right angle triangle, and we get a rise of 1 and a run of 1. Distance change is 1, time change is 1, distance over time, and so we get 1 over 1, which equals, oh, didn't have an equal sign in there, 1 over 1, 1 kilometer per hour. DE, okay, we can go a little bit faster. There's no change in the distance. There is a 5-hour change in the time. Distance over time, we get 0 over 5 equals 0 kilometers an hour. He's in the school. School's a fixed point. His distance is not changing. He's stopped his motion. EF, we find our 2 clear points. Here's one point. Here's the other point. This point here is at 7.5. E is at 7.5. And in terms of distance, it's 4 kilometers away. If we draw our right angle triangle, it's like this. What's the rise? 4. What's the run? 0.5. So distance was 4. time was 0.5. 4 divided by 0.5 and we get 8 kilometers per hour. Use your calculator if you're not sure how that worked. Okay? But 0.5 goes into 4 8 times, and so his speed is 8 kilometers an hour. So this is how you determine the speed of each line segment, and we did an example of this before, but I thought it'd be really important to show you it again. And let's move on to activity 2. Looking at activity 2, I'm just going to do the first graph with you. It says find the speed in each of the distance time graphs below. Very simple. We just did it. We find this point, because we can clearly identify them. We see we don't want to use this point because we don't know exactly what that point is. Is it 1.3, 1.4? I don't know. Can't use that point. I'm going to use the start point and the end point. It doesn't always have to be the start and end point, but it needs to be 2 points you can clearly identify. So this one is 0, 0, and this one is 2, 3, and I'm going to go up and draw my right angle triangle. I go up 3, I go over 2, 2. So what's my rise? 3 over 2. We'll put it down here, 3 over 2. And if I do 3 divided by 2, what do I get? 1.5 kilometers. I get the kilometers from here per hour. Okay, so what are your units are going to match with the units that are listed on the axes. All right, you should be able to do the next 2 graphs on your own. Let's look at the next one here. And for this one, I'm gonna do the middle one, and then you can do the other 2 on your own. So for this one, 2 points that I can clearly identify. I could choose several points. There's this point, and that point are all clearly identifiable. I'm going to take the middle point and the first point here, and I'm going to draw my right triangle. And how much did I go from 40 to 30? Now remember, you have to pay attention to what is on the y-axis to do this accurately. There's a difference of 10. What about from on the x-axis? We are going from 0 to 4. And so our rise is 10, our run is 4. 10 divided by 4, and we get 2.5 kilometers per hour. Again, as I said, I'm going to leave you to do these 2 graphs on your own. You should be able to do them now. All right, activity 3. Activity 3 has us draw a line that represents the speed, represents each of the speeds shown. I should just say the each. All right, draw a line that represents each of the speeds shown. And when we do that, we could start really anywhere on this graph here, but what we'll do is we're going to start at 0, 0 for all 3 of them, and I'll use different colors. I'll use this green for that, I'll use purple for this one, and I'll use red for that one. Okay, so if I'm going to draw a speed that is 10 kilometers per hour, where would they be after 1 hour? They drove 10 kilometers in 1 hour, so at 1 hour they're going to be 10 kilometers away. At 2 hours, they're going to be 20 kilometers away. At 3 hours, they're going to be 30 kilometers away. At 4 hours, they're going to be 40 kilometers away. Each kilometer they're driving 10 hours, so each hour they're driving 10 kilometers. And so I can do the number of hours times 10, and that gives me how far away they're going to be. So my first line is like this. All right, what about B? B says 40 kilometers per hour. If they're driving 40 kilometers per hour, how far will they be after 1 hour? Hopefully you got it. They'll be 40 kilometers away. And so starting from here, that's what that line is going to look. It shows a speed of 40 kilometers per hour. What about C? 5 kilometers an hour. If they're going 5 kilometers an hour, at 1 hour they will be 5 kilometers away. So right in the middle here, between 0 and 5 on the y-axis. How far will they be after 2 hours? After 2 hours, they'll be 10 kilometers away. Now, hopefully your graph is a little better. Mine got to be right in the middle, otherwise it starts to look curved, and we should only be working with straight lines. 3 hours, they're going to be 15 kilometers. And then finally at 4 hours, they'll be 20 kilometers away. So roughly like this. Okay, now that I've done this one for you, you should be able to do this other one, try and do this other one on your own. So that concludes this video on section 5.2, Interpreting Distance Time Graphs Part 2. You should be able to, based on this video, complete that handout that you've received. If you do have any questions, please make sure that you reach out and ask. I will be happy to help you.